All right, one. It's October 12th. So another easy one, as you guys can see. So we'll see how fast we can do this. If we can do this fast, I say maybe within 15 minutes, I'll roll another one. Before I start, I just watched Mr. Llama playing Diablo 2 Resurrected. A crazy, crazy run. Hardcore. Like it's more than hardcore. It's no health potion, no no merch, no TP back home, and no everything. It's just his character going through everything. That's if you lose life, you just lose life. You can only get it back when you level up. It was crazy. It was the craziest thing I've ever seen. And as skilled as he is, he was not able to beat it. So this is some next level stuff. Really next level stuff. All right, let's get to what we have today. Guess number, higher or lower? It seems like binary search to me. All right, higher or lower? Not a lot of people do this, huh? Oh, it has a solution too. All right, a guess game. Pick a number from 1 to n. You have to guess which number I picked. Okay. Every time you guess wrong, I'll tell you whether the number is higher or lower. Yes. When implement this, which returns 3 possible results. -1 if the number I pick is lower than your guess. 1 number is a lot higher as equal. Return the number I picked. So if I give you, what is n? I'll pick a number from 1 to n. And then this is the picked, so I need to return. Okay. Yeah, it's binary search. The guess API is already defined for you. Okay, the guess. Wait, what? What am I supposed to implement? You call a predefined API. Oh, I call this function. I call guess. I see. I call guess. Okay. Well, we cannot test this ourselves. So basically, you just guess the middle, we guess, and then results. Yeah, that's binary search. Yeah, let's still write it, even though we cannot. I mean, binary search is, if you write a bare bone binary search, the tricky part is always the edge case, right? Where do we stop? And different binary search requirements might result in different stopping conditions. For this one, I'm thinking, I don't know. I mean, it can be just like very generic. It can be very generic. So when I call guess, right? So we're gonna say low and high, right? Yeah. So low, high is going to be 1 and n, right? Oh my god. And we say while low is smaller. Now, that's the first case. Do we say smaller to high or smaller equal to high? I think it's smaller equal to high, because if it's equal, we want to go through. And then we say mid equals low plus high divided by 2. And then we just call this if guess mid is larger than 0, right? So we're too big. So high will equal to mid minus 1. Now we can do mid minus 1 because it's smaller equal to, so we'll go back. Now if we say smaller, then we have to decide one of the ends cannot do -1 or +1. So let's call it twice. So we call verdict equals guess mid. So we'll call it once. So verdict is this. Now if verdict is smaller than 0, that means our guess is too small. Then we say low equals mid plus 1, right? And then finally else we return mid, which makes it good. And we'll definitely find 1, so we don't have to return at the other side. So, all right, let's roll this console, all test cases. Let's try. Oh, My God, I gotta know. What? Wait, how? How we gonna know? Wait, what did we do wrong? Mid equals this, right? So if a 10, that gives us 5. So we go 5. 5 is too small. Therefore, low is going to be, so now we're going to be 6, right? So 6 and 10 give us 8. It's too high, so we go to 7. 6 and 7. 6 and 7 give us 6. Right? 6 and 7 give us 6. And then it would be this. So I return the mid. How did I not return mid? All right, this is a troublesome. And the last one we didn't return either. Huh. Hold on. Let's take the last test case, and let's just debug this. Let's print low and high. Kind of take a look what happened. We have 1 and 2, right? So 1 and 2 coming in. Low is 1. Mid is 1. 1 plus 2 is 3. It's going to be 1. Oh, wait, 1. Guess mid 1. 1 is, that should be this. Low will be mid plus 1. Low will be 2. All right? So 2 coming back. How did... What happened? I don't understand. Mid. Now what? We do vertex as well, so get all of them out. If number is lower, okay. Oh, if my number is higher. Ah. Oops. My number is higher. This shall do. I got it wrong. I thought if my number is higher, which means my number is lower. So if my number is lower, it will be negative. Right? So if it's negative, my number is lower, so my guess is too high. So that shall do. Use example test case. This one shall do. Yep. All right, submit this. There we go. Oh, wow. Only 18% ranking. Why? Why so low? Oh, well, I mean, I don't know. So this is just binary search, right? Just binary search. That's it. We can call it O1 login. Oh wait, O login, not even O, just low login. We had 46 milliseconds. It'll give us only 18, but that's probably because it's not too much a spread. But take a look. I don't think there's too much spread on the runtime. Oh, there's a spread. Huh? What are these? 32. It's the same thing. It's the same thing. All right. Nothing else to see. Let's see the solution. Brute force. Oh, you can do brute force. Binary search. Binary search. Blah blah blah. Equal blah blah. And then yep, binary search is fine. We have another one called ternary search. We choose 2 pivots into 3 equal parts. Why do we torture ourselves? Because the runtime is the same. It's almost the same, right? Alright, so, oh my god, the recursive function we have to, yeah. This is a master theorem that you can use to determine the runtime of a recursion relationship. I forgot. I forgot how that one is done. Anyway, so let's log 3n. Since the value of this is greater than 1, ternary search does more comparisons than binary search in the worst case. Okay. And I'll go quadruple for 5 times. By not, hold on. This is Pokemon speaking. Gotta take a look. Can be shorter and faster by not specially treating the unlikely. Also, kind of much faster than. This. To magnify the time, which one should accept it. Wow, mine accepted. Let's need rest smaller than 0. Check. Micro optimization. Cost overflow. Yeah, but this just makes sense, right? We don't check this, so we only check this, and then we come out. Yeah, see, this is another thing. Like when the while condition doesn't have the equal sign, then one of them cannot be stepping overboard. So you do low. The high doesn't get closer, but the low keeps getting closer and closer, and eventually, when it jumps out, the low will be the result. Yeah, but it's basically just binary search. Okay, so that's that, and we got it done pretty fast. Let's roll another one. Record this. Let's roll a medium. Let's do a medium one. What's this? This is 374. Right? It's 374. All right, let's roll a medium one. How do we do this? I don't know. So we go to problems, and then I think we can choose. All right, difficulty. Okay, let's choose difficulty. Medium. All right, and then pick one. Describe the painting. Nice. No solutions. And 1,943 is a new problem, fairly new. All right. Ooh. This is something we have to put some effort in. There's a long and a thin painting that can be represented by a number line. The painting was painted with multiple overlapping segments, where each segment was painted with a unique color. We are given a 2D integer array where segments I, start, end, and color represents the half-closed segment start to end with open here, with color I as the color. The colors in the overlapping segments of the painting were mixed when it was painted. When two or more colors mix, they form a new color that can be represented as a set of mixed colors. For example, 2, 4, 6 are mixed. Okay. For the sake of simplicity, we should only output the sum of the elements in the set rather than the full set. Okay. You want to describe the painting with a minimum number of non-overlapping half-closed segments of these mixed colors. these segments can be represented by a 2D array painting where painting J, blah, 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 describes the half-closed segment with a mixed color sum, okay? For example, the painting created with 145, let's do this, 145, so we're talking about 1 to 4 with the color 5, and 177, so 1 to 7 with a 7, so it's going to be 1 to 4 with the color 12, and 4 to 7 with a color of 7, right? So that's what we return. 1 to 4 is a colored 5, 7, some 12, or 7 is 7, right? So we return the 2D array painting, describing the finished painting, excluding any part that are not painted. You may return the segments in any order. A half-closed is segment number line between A and B, including A and not including B. All right, examples. So we are given 145, 477, and 179. So we're going to return 1414 and 4716. Okay, makes sense. 179, 6815, 810, 7. So we're going to do 169, 67 is 24, 78 is 15, and 8 to 10 is 7. Good. Last example, 1 to 4 will be 12, and 4 to 7 will be 12. Can we return with only 1? Because these are the same. The returning 1 to 7 is incorrect because the mixed color sets are different. Huh. It says the mixed color sets are different. Oh, so, but, what if I gave you this? Test. This has to test. What if I gave you this? 145, and then again 47 is 5, and 57 is 7. What if this happens? Because you're asking for the shortest, right? We're asking for what's the return? With a minimal number of non-overlapping half-closed segments. So this one shall return 1 to 7 with 12. Colors are not distinct. Colors are distinct. Each color is distinct. What does that mean? Each color is distinct. Therefore, it is not possible. If the colors are distinct, then that means there won't be two segments cannot be combined. But if they are they must be like for a full, like if originally it must be a full segment, it won't be like I have a segment and I have another segment and these two segments can be combined together. That's not possible because the colors have to be distinct. All right, so first thought, union find, but not sure if that is the case. All right, let's just focus on example 1. All right, so I have, this is ranges, right? So we can sort it, right? Let's sort it based on starting point, right? Sort it based on starting point, and then based on the end point. So after sorting, we'll have 1 to 4, 5, 1 to 7, 9, and then 4 to 7, 7. So after sorting, that's the outcome we want. So size. Yeah, that's basically actually I'm sorting based on size, right? We sorting based on the left and sorting based on the size, which is also like based on the right. So we have the smallest to begin with. And then we'll look up for the second one. The second one is 1 to 7 with 9. So we can combine with first one because we know the first one. Oh, we're going to compare, right? We're going to compare the starting point and the previous one. If the starting point is larger than the previous one, then the previous one will be added to the result. No question, it means there's no overlapping. If this is smaller than the endpoint, then we have overlap. So we need to first compute the part that is not overlapping, which is from this starting point to this starting point. Now we have 0, so there's nothing. So we don't consider that. And then we consider the overlapping part, right? So we say to end here, right? The endpoint of this compared to the endpoint of this. So these two we can find, but this one will definitely be not smaller than that, right? If this is not smaller than that, that means we'll compute, then this will compute an overlap, right? Overlap will be the bigger between these two and a smaller between these two. So that's the overlap. When we get the overlap, when we get the overlap, we cannot immediately count it because we might have another one. Huh. Interesting. Let me think. Let me think. Yeah, we cannot. How big are we talking about? 2 times 10 to the 4th, okay. So second one, we can find the overlap, that's fine. But after we find the overlap, this one gets chomped, right? This one is chomped. So shouldn't the remaining going into priority queue? Is this priority queue? Priority queue based on the starting point. All right, think about it again. Priority queue based on starting point. So we'll get the first one out. Okay, we'll get the first one out, and then we pop out a second one, and then we compare these two, right? And after we compare these two, because we have a limit on this, right? This one, so every time pop out will be a strip with the smallest left point. So we pop out another one, and then we compare these two. Anything to the left, right? Anything to the left that's chomped off will never be overlap with anybody else. So if we have anything on the left side, they can go to the result. And then the mixture has to go back into, no, we don't go back. The mixture stay outside, right? The mixture stay outside. And then the chomped off, like this part. So from 4 to 7 with a 9, we'll go back into the priority queue. And then we wait for the next one coming out. Still comparing to this mixture. And every time compared to this mixture, we can chomp off a little bit more, chomp off a little bit more, until the next coming out will be 4 to 7. So 4 comes out, and we see 4 and this does not have overlap, so this entire thing gets chomped off. Then this, the new thing come out, becomes the new, like outside, right? Becomes the new outside. And then, okay, this seems to be working. Let's try this. What do we do with this? I mean, that's not today's challenge. How do we do this? It's not today's challenge. Do we just, let's see. Our structure is we have these challenges. They has to be challenged. But we also have these things. They're just random questions I do. So I just do it that way, right? Just do it that way. So basically, I'm gonna close on this, and we're gonna say copy. Do this one's what? LeetCode. What's the number for this? 1943. 1943.py. Okay. So st LeetCode 1943. All right. Let's try this. priority queue. So in Python, priority queue is going to be import heap queue, right? And then remove all this, copy this one in. So we need a priority queue, right? So we say, oh, we can turn entire segments into priority queue because I think by default it's gonna use the first variable, right? We can turn the entire thing. So we just say pq equals heap queue dot was that heapify? I don't know, I forgot. Let's see. Python heap queue. Push, heapify, transform in place in linear time. So we can just heapify it. We cannot push, just heapify. So we can just say heapify segments. Oh, we're changing segments. Then we're not having this. So it says in place, right? Heapify is in place. Heapify transform x into a heap. In place, linear time. So segments is a heap. And what do we say? We say mixed equals heap queue dot heap pop, right? Segments. And then I'm going to say while segments. And also result equals this. Right? So I say while segments. I say new paint equals heap queue dot heap pop segments. Now when I compare these two, oh, hold on, but it's not guaranteed because we're only measuring on the start. We also want it to consider two levels, right? Heap queue comparison for two levels. Man, we have to create our own class for this. No, it's fine. It's fine because it doesn't matter. Even if 1.7 gets popped out first, we do 1.5, right? All we want is just overlap between the two. That's it. And not just overlap. We find if there's anything on the left, and these will be popped. If not, then we just go. Yeah, we just go find the overlap between these two, and then they're gonna become the new thing, and then we will chomp off whatever that's left. That's fine. So the new paint coming out, right? So we know that, and that's a min heap, right? So heap is a min heap. Blah 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 blah. Heap 0 is the smallest item. Yeah, that's a main heap. So that's good. It's good. So when the paint come out, we're gonna see if there's anything. So we say if, right? If what should I call it? If paint 0, right, which is the left side of is larger than mixed 1, right? No, not mixed 1, mixed 0, right? If paint 0 is larger than mixed, if paint 0 is larger than mixed 0, then we have a left side, and that side needs to be pushed. Then we just say rest.append. New is going to be mixed 0 to paint 0 with a color of mixed 2, right? Yeah, that's chomped off. This is what we call chomped off. And after that, we're gonna modify mixed, right? So mixed is gonna be modified such that mixed 0 is going to be equal to paint 0, right? That's that. And after this is done, then the starting point is the same, then we're going to compare the end, right? We'll compare the end. How do we compare the end? So we say mixed if paint 1. Now, it's not actually, it doesn't matter which one is bigger. We are just going to set, but it does depend on which one, right? Is I'm going to put the paint back or put the mixed back? That's the thing. So we say if paint 1, we're going to fix the mixed color. So mixed, but also depends whether they overlap, right? So we say paint 0 is larger than mixed 0. This is not right. This is not right. So it's actually going to be this. All right? If paint 0 starting point is larger than mixed 0 and smaller than mixed 1, that is the condition. That means the two have overlap, right? As an overlap. So if that happens, then we do this, right? So elif paint 0 is if paint 0 is larger or equal to, right, mixed 1, right? So that means the entire mixed is gonna go, right? The entire mixed is gonna go. So if that's the case, then rest.append the entire mixed, and the new mixed is equal to paint. That's the new mixed, right? And then we keep going. Else. So this is the case where, no, that's all the cases. That is all the cases. So after that happens, and then we need to consider on the right-hand side, right? So we need to say if no, we can actually say mixed the color. We know the color. The color of the new mixed. And no matter what, the color of the new mixed can be determined, which is going to be paint. And because every color is unique, so we can just add them together. So it can be paint, so it can be plus equal to, right? Paint 2. So we get a new mixed color, and now we're going to determine the right side, right? The right side. The right side is going to be mixed 1. It's going to be the smaller of mixed 1 and paint 1, the smaller of these two, right? That's mixed 1. And then we need to add something. We need to say heap q dot heap push. And I believe heap push, we need to put heap an item, right? Heap an item. So we're going to do heap an item. So heap is going to be segments. And we're going to push one thing back, which is after mixture, we have the remaining. So the remaining is going to be new thing, right? It's going to be mixed. Oh, but we don't know the color. See, that is the problem. We don't know the color. The color is depends on. So we say if, right? If mixed 1 is larger, right? If mixed 1 is larger than paint 1. Actually, let's do smaller than paint 1. Right? If mixed 1 is smaller than paint 1, then the one we push back in is going to be mixed 1. That's the starting point. And end point is going to be paint 1. And the color is going to be paint 2. Right? Let's do it this way. If this, else, right? Else, so we're going to do this, we're pushing this, if mixed 1 is smaller than paint 1, so we basically put paint back in with change on mix, Otherwise, if mix is bigger, right, mix is bigger, then we're gonna push in still mixed 1, but the end is gonna be mixed 2, and the color is going to be, no, that's actually, wait, hold up. We already set mixed 1. Oh, shoot. We should not. And we should not change the color yet. Yeah, no, we cannot do this. All right, let's scrap this. Let's just say if mixed 1 is smaller than paint 1. Yeah, I have to do it this way. If mixed 1, right, the mixed end is smaller than paint the end, right? In that situation, let's push something in first. So we're gonna say it's fine. Actually, that's fine. We can do this, right? Then we say mix of 2 will be plus equal to paint 2. That's cool. Mix 1 is equal to the smaller value of 1 and this, but because mixed 1 is already smaller than paint 1, so this is not necessary. All we need to do is this, and then we need to push something back in, which is mixed 1, paint 1 is bigger than the paint 2. So that's, yep, that's that. I probably can just put it up to open a new line. All right. Else, if mixed 1 is larger than paint 1, right? If it's larger, then basically we need to do some swapping. So we need to first push. Now we're gonna change, so it's gonna be mixed 1 is larger, so we have the end, so the starting point, and how can we do it nicely? So we can say mixed all right, mixed 0 already, so we have mix is here, new one is here, so we can say mixed 1, but we don't want to change the mix yet, right? So let's push first. So we say heap q heap push segment. Let's push it first. So we're gonna push a new thing. That is going to be mixed. No, not mixed. It's paint 1, right? Because paint 1 is smaller than mixed 1. So paint 1 and end in mixed 1. And the color is going to be mixed 2, right? So that's the thing we push in. And after we do that, we're gonna reconfigure mixed. So we're gonna say mixed 2 plus equal to paint 2, right? And mixed 1 is going to equal to paint 1, right? Can we combine these together? Let's see, we have the same thing, right? These two are the same. Yeah, we can do that. I think this one, we can just get this out, because we're repeating, right? We just say if it's smaller, we're gonna chomp off. This is the part that chomp off, we push back in, and this is the other thing that's chomped off. We're gonna push in, and the only difference is in this case, mixed 1 does not change, but in this case, mixed 1 needs to change. And this one we chomp off is the chomp off the mixed, right? We chomp off the mixed, so we have to use the original mixed color. And then when it come out, we update the mixed color, and then we go back. All right, and then we're gonna return rest. All right, let's give this a shot. Okay, so we have a bunch of test cases. That's good. Always nice to have good test cases. Okay, that's the first one. This is the second one. I think these test cases are pretty comprehensive. It's better than my test case, right? Alright, this is the last test case. Alright, and as usual, I don't like these not parentheses, these commas. Yeah, I go the Python style. The commas needs to have a white space. So this would be segments. This is split painting segments, and to make sure, so we're gonna sort it. Sorted res equals sorted answer. Run it. Not right. Okay, so for the first one, let's just focus on the first one. 144. Oh wow, that was very wrong. 145. How do we have 145? 145. Is the second one coming out? Hold up. It's print paint, print mixed, and paint. So mixed is this, paint is this. That's correct. Then what do? We say mixed is 0. Paint 0 is this. If it's smaller, let's handle it different. I think I didn't handle this one. Let's just say smaller or equal to, right? If it's smaller or equal to this, then we'll have 0, 0 situation. And then this situation is not considered. Smaller or equal to and smaller, right? And if it's smaller or equal to, we're going to append mixed 0 and this 0, but we're going to see, right? We're going to say if mixed 0 is smaller than paint 0. So if they're the same, then we don't do it. So if this is the case, then we append. And then we change mixed, and if mixed 1 is a 4, is smaller than paint 1, that's true. Then I'm going to push mixed 1. I'm going to push a segment, which is mixed 1, was it 4, paint 1, 4, 7, paint 2, 9, 4, 7, 9 can be pushed in. And then mixed, this one might be right. Let's try this. Yeah, this one's correct. So we need to add this and also handle this. Let's remove the print statement. Ugh. I was not right for them. Okay. All right, we have a 4, 4. That is now correct. Why do we have a 4, 4? Let's handle this case first. Well, let's see. We handle, so these two will come out first, right? So we have mixed is not, right? So mixed is 0. So these two will set to the same, which is, they are the same. And 1. I say if the first one is smaller than the second one, then we do this. Else, which means the second one is larger or equal to. No, it has to be Aleph mixed 1 is larger than paint 1, right? If not, but in this case, right? In this case, this doesn't suffice. It doesn't satisfy. This doesn't satisfy. So we don't do any of this. So all we do is mix 2 and add it, and it's still going to be mixed on the outside. So 1, 4, 12. Okay. Well, where is 4, 7 go? So we got 1, 4, 12, which is after this round. The next one coming up is this. So the mix is still on the outside. And then we say, oh, it's in the memory. It's in the memory. It was not pushed in. So mixed equals paint. All right. And then next one come up with this. All right. And then this one satisfies this and going through and nothing. So whatever is remaining. So we're going to say res plus mixed. The last piece of mixed. Oh. Nope. No, mixed is how wait, what is mixed at the end? Oh, of course we cannot. So I just need to do res.append mixed. It's this res plus this mixed. There we go. Right, try it. Now I think we're good to go. All right, let's give it a shot. Again, I'm going to run the same test case again, just to make sure that everything runs smoothly. Okay, accept it. Let's hope there's no edge case. Well, we can test some edge case. I mean, the simple edge case is just this, right? That's one edge case. Yep. All right, let's try it. Submit. Submit. Okay. Pending. Judging. Oh, keep judging. That doesn't look nice. Do we time out? Yep. Timed out. Oh, dear Lord, look at this. Look at this. All right, so we timed out. Let's take a look at the details and see how many test cases we've passed. About a half. I'll pass about half. All right, we gotta be smarter. We gotta be smarter. Okay, so this one TLE. I mean, the thing is, every time we push, we have to push it back, right? That seems to be, that's bad. Okay, let me see. I think I'm gonna go back to the sorting. If we sort, right? If we sort, and how do we handle the leftover? Like, we can chop this off, that's fine. And this is current mixture, that's fine. And then, what about the leftover? Well, the leftover will always be, if you think about it, the leftover will always be at the same position, right? That will be the new mixed, right? The leftover will be the new mixed. If we sort, hold on. If we sort everything based on the starting point, right? So we have this coming out, and whatever, and then we'll have a piece of leftover, right? And then the next one comes in. Yeah, that would be hard to reason. So, no, let's say we sort it in such a way that we sort based on the starting point and also based on the size. based on the size. So if the starting point is the same, then the smaller one goes first, otherwise, yeah. So if we sort it that way, and the new one comes in, we're guaranteed that the new one's endpoint will always be bigger than the previous one's endpoint. And new one's starting point will always be bigger than the previous one's starting point, bigger or equal to. So we can have, so chomp off, that's fine. And then we'll have a mixture. So we have a mixture, right? So we have a mixture, and then we'll have a leftover. So the mixture and the leftover. So then the new one comes, and we guarantee the new one will have this, and then it will extend longer than that one, right? Then what do we do? Well, then we will chomp off this. This will be the new mixture, and then we have a second mixture. See, that is the thing. And we have multiple mixture. We have lots of mixture, but that's fine, right? Hold on, is that fine? I mean, it's gonna be like a queue, right? It's gonna be like a queue. It's like a shifting window, right? Every time it goes in, it's like a shifting window. We have all the potential mixtures, right? We have potential mixtures line up in that queue, and every new thing comes in, we're going to just loop through that queue one by one, and then we just going to determine, so somewhere got popped off, so how long is that going to take? How long is that going to take? I don't know, man. Hold on, I have one thing to try. Usually these things is, we'll take this. Oh my god, eyesore, so many. Let's see how long it's going to take just to run this test case. It's kind of like a benchmark to see if our next algorithm is going to improve. Yep, it's going to time out. So the next benchmark needs to improve based on this. Okay, so we have, so as the new one comes up, if the new one is large, right, it's expanding a long distance, and then they're going to be chomped off into small pieces, and the new one comes up. If it's the same, then it's going to be, then it has to go through the same thing. I'm just thinking if it's possible for the queue to grow to too big a size. Everyone come up will have a smaller one, and then one comes up, gets a bit bigger. The next one will be definitely go here. And we can try. We can try that idea. Let's try. Yeah, so we're gonna have a sort. We're gonna sort it. Okay, let's sort this first. So we're gonna say segments.sort, right? And then key, no, key equals lambda element. I'm gonna turn element 0 and element 1. So basically we sort, yeah, I'm pretty sure you don't have to do this. I think it's by default it will sort based on each key, but just to be more explicit. And then let's use this from collections, import deck. I'll use deck. So we're gonna call it a queue equals deck, right? And then the deck will represent the strips that's outside, needs to be handled. So we're gonna loop through every single one in a segment. So I'm gonna say for seg, that's actually paint, right? For paint in segments, right? If not q, then if not q, then q dot append, right? Q dot append paint. That's it. Else, if there is something in the queue, then the new paint need to go through everything in the queue, right? Then, what do we do? Hold on. We're going to produce a new, then that's not necessary. We can just use two lists to handle this. Else, we have a temp equals this, all right? And now we just go every single one in the queue. So for mixed in queue, right? So for mixed in queue coming out, and we have a result as well. So res. So for each mixed in queue coming out, I have my current paint. Now, the guarantee is, there's actually no guarantee. If we do it this way, there's no guarantee. Oh, there is a guarantee that the beginning of the queue, the left side, will definitely be smaller than me, smaller equal to me. So we can always, so when I chomp off, so that piece is going to go into the result. After that, right, after we have this piece and we have me, right, we have me. And after that, we're going to chomp off again, so that's the mixture, right? So when this mixture is going to go to the temp. And we have the remaining, right? We have that remaining. And then the next one inside the queue will mix with that. And that we have a new thing, right? We have a new thing that goes in. And we have this. And because the next one coming up will always have, no, that's not, is it? Yes, the new paint coming out will always have a larger endpoint, right? We'll always have a larger endpoint. So when we go, so we'll always have a larger endpoint. So whatever's in the queue will have a shorter endpoint. So everybody is going to mix with that one, right? And chomp it off, mix, one not. Doesn't really matter. And at the end, I'm thinking at the end, so everything come out, chomp, right? And at the end, it's always going to be the new piece going to be added into it. Okay? So for mixed in queue, so every mixed coming out, so we're going to compare, right? So we say if mixed 0 is smaller than current paint 0, right? When that happens, if mixed 0 is smaller than paint 0, then we're gonna push sum to the result. But then there are two situations. The mixed end could be like this, or it could be like this. Let's just separate these two situations. All right, so we say if mixed 1 is smaller or equal to paint 0, right? So in that case, definitely res.append mixed, done deal. Else, all right, else for each mixed, else, so mixed 1 is larger than paint 0, then we need to say elif, all right, Now just else, if mixed 0 is smaller than paint 0. In that case, rest.append, the new thing is going to be mixed 0, right? Paint 0, and then mixed 0, paint 0, and then mixed 2. But after that, we can continue. So we just know the paint 0 is inside mixed, right? So we need to create a new thing, right? A new thing. But also depend, yeah, that will create a new thing. So what type of new thing? So we can say the new thing is going to be temp and .append, right? A new thing with a paint 0, right? Paint 0, that's the starting point. End point is going to be mixed 1, because mixed 1 will always be smaller or equal to paint 1, because we sorted it. So it's be mixed 1, and then the color is going to be mixed 2 plus paint 2, right? So this we're going to add that to temp, and that's the part gets chomped off, right? It's chomped off. Now, once we add that part, then the paint needs to change, right? The paint needs to change because I already mixed with this. In the next segment, yeah, we need to change the paint. So when that happens, so temp append, this is the new piece, and then paint 0 is going to be mixed 1, because from paint 0 to mixed 1 already is the new mixed part. So the paint 0 is a paint 0? Yeah, paint 0. The starting of the paint needs to be mixed 1. It's to be mixed 1. Okay? That's also like if mixed 1, and we know mixed 1 is larger than paint 0. Mixed 1 is larger than paint. Mixed 1 is larger than paint 0. So when we mix paint 0 to mixed 1 is mix. So mixed 1 is the starting point, right? So mixed 1 is the starting point, and paint 1. Now the question is, do we continue? Well, we can continue, but we need to check, which means we need to check. Oh. Yeah, so we do this, right? And then we're gonna come back up, the next mixed. So the next mixed 1, we're gonna check with the paint 0. If mixed 1 is smaller than paint 0, which can happen, but not after we have this, because it's paint 0 if it's equals to mixed 1, the previous one, and the next one coming up. And the next one coming up, the same thing. Right, the same thing. And then they're going to compare. But if the new strip, right, the new strip, so paint 0 equals mixed 1. And if paint 0, if mixed 1 is smaller than this, else this. And if paint 0 is larger or equal to, it shouldn't be larger than, but just in case, larger or equal to paint 1, right? That means paint 0 has already been all used up. In that case, we just say temp.append mixed and continue. So this will produce temp, and after temp produced, q is equal to temp. So now we go back to find the next one, and at the end we return res. I'm not sure. Let's try this one out. Oh, what the hell? Maybe we need a parentheses. Okay. I think we're having the same problem as before, which is we need to add something at the end. What should we add? So paint, segments, right? And then everything is inside Q. And then we have a new one coming up. It will pop whatever, and so it should add Q, right? So it should add Q. No, wait, Q is empty at the end? That is bonkers. Hold on, that doesn't make any sense. All right, one at a time. Let's see this one. Yeah, we just missed this one. So in our case, we will start with 1, 5, right? And we get 1 to 9. Ah, I think the logic is not right. A new one might have smaller. Holy guacamole. Okay, so we have this. Let's just do the current sorted way. So we have this, and we add this, which we did at 1, 4, 14, right? And the remaining is from 4 to 7. So your campaign is 1, 5. Yeah, let's at each step, let's try print Q and paint, like the current paint. So 145 is the Q, 179 is the new paint, and once we done that, because paint 0 is not like this one not due, so mixed 1 is smaller, no. So we say if mixed 0 is smaller than no. So temp we're gonna append paint 0, which is this, and then mixed 1, and add it together, which we add a 1 for 14. Yeah, that's true. And paint 0 equals mixed 1. Shouldn't we add that to the... Yeah, we didn't add that to temp. Oh no, because we're looking through everything, but at the end, the next mix, we need to use the same paint, right? We need to use the same paint to handle. All right, at the end, when they all come out, there's a paint still left, because paint 0 equals mix 1. So we have 4 to 7, right? 4 to 7, which means we didn't go to the next one. Now 4, 7, 7, but we have a 4, 7, 9. That one is missing. Yeah, that one's missing. So once we're done, right? Once we're done, and paint 0 is come. So if we still have paint 0, so which means if once we all done, we can just say, let me just say, we can just break here. So if this, break. Nah, it's fine. It's fine. We just check again. So we say if after everything, paint 0 is smaller than paint 1, right? Which means we still have some paint left. Then temp.append paint. And then we do this. All right, this one works. All right, let's not do this. Let's try the other two. All right, they all pass. All right, give this baby a shot. I mean, we have this. I don't know. Like, are we saying everything? I don't know. I don't know the complexity. I'll worry about this later. Pending, judging. Oh, we got a wrong answer, which is an improvement, right? It's better than, but it's a wrong answer. We don't like wrong answer. All right, how do we handle this? Well, we can handle it because we have a TLE, which means this solution most likely is correct. So we're just gonna create our own test case. So we'll go from random, import randint. Wow, this is a full effort. So the test case, so we have solution 1 equals to solution 1, right? And then tests. We're going to generate our own tests. So tests equals to going to be this for, right, for this in range num test. So I'm going to say num test, that's a 10, right? And each value, let's use this, second in length. So this is going to be this for this in range seg length, right? So seg length, let's say 4 seg length, and within is 3. So within when it says 3, so it's going to be randint something, randint something, and randint something, right? But these two, okay, that's the requirements. Huh. How do we satisfy that? I don't know. All right, so logic is too complicated. Let's do it this way. All right, so for this, right, and then test equals this, and then for this, all right, for this, we are going to create test a paint is going to equal to this, right? And we have to say paint equals this. So let's just say 1 to 10 to the 5th. Okay, let's say 1 to 100, right? So both are 1 to 100. This one doesn't matter. This one can be really huge. 1 to, let's go 1 to 100, right? And we say if paint 1 is smaller or equal to paint while smaller or equal to paint 0, then we redo it. It's just while true. Do this, and then we say if this is larger than, then we break. Then when we break, we say test.append paint. Right. So this will acquire the tests, and for it's not going to be answer, so we have no answer. So it's just going to be I segments, right, in enumerate tests. Result equals to sol, answer equals sol1 dot split painting segments. If this, all right, let's try this. What is this? What is this? We're supposed to print something. What? No, there's nothing. Shoot, tests. Oh, I forgot to add it to tests. So tests.append test segments split. Where? Oh, forgot this. Solution 1. Oh, that is not correct. So many things not correct. All right, we have a lot of issues. It's one test. Wow, that is, answer is this, result is this. I want a test. So else print test, fail answer, result, test. Huh? I consumed it. Dang. Dang it. Oh no, wait, it's segments. And also I changed the segments. I need to copy it. Oh, it has to be deep copy. Mamma mia. Deep copy. From Python has deep copy. Hold on. Python deep copy. Wow, this is very invested. Shallow and deep copy operation from copy, import deep copy, right? I think it's, yeah, so from copy, import deep copy. So we need to deep copy this thing. Because we're making, yeah, these are not pure functions. Neither of them are pure functions. So we're going to say deep copy this and deep copy this, and this is not test, this is segments. There we go, now we pass. 10. Oh no, now we fail. Oh, we fail badly. All right, so how about the 4 tests? 0, 1, 2, 3 pass. Okay. Answer, result, test. All right, too much. Let's go 2 segments. 1 segment. 1 segment all pass. 2 segments. There we go. That's what we can start working with. 2 segments. All right. Let's focus on the first one. 12, 34. That's way too big. Come on. 2 segments, 1 to 10. All right, 1 to 10. Let's go 1 to 10. Everything 1 to 10. There we go, 1 to 10. So we have 6, 7. Okay, so 6, 7, 8. 6, 7, 8. And 5, 10. 5, 10, 1. Okay? So the result should be 5, 6, 1, 6, 7, 9, and 7, 10, 1. That's true. My result, 5, 6, 1, 6, 10, 9. 6, 10, 9. All right. What's the problem? So this one come out for paint. So after sort, we shall have 5, 10, 1, and 6, 7, 8, right? That's after the first sorting. And then for paint in segments, so 5, 10, 1 goes into the queue. Next one coming out is 6, 7, 8. So 6, 7, 8 comes out. For mixed is 5, 10, 1. 5, 10, 1 come out. So 5, 10, 1 and 6, 7, 8. So if paint 0, 6, 7, 8 is paint. 5, 10, 1 is mixed. If paint 0 is larger or equal to paint 1, which is not, right? Which is paint 0 larger or equal to paint 1, which is not. So we don't consider this. If mixed 1 is smaller or equal to paint 0, no, that's not. So we don't do this. So if mixed 0, which is 5, is smaller than paint 0, it is. So we append mixed 0, paint 0, and paint 0 and mixed 2. So 5, 6, 1. That's what we got for 5, 6, 1. That is cool. When we've done that, we say temp.append because we do that, and we're going to say pen.append. Why do we do temp.append immediately? We just chomp off one side, right? And then we have the remaining. Now we need to compare. It's not going to be mixed 1 because mixed 1 is bigger. That's where the problem is. Mixed 1 is not likely to be smaller. So for each one coming out, we have to compare. Right? We have to compare the mixed. Like the end of mixed. So we have the end, we have something end of mixed, and then the new thing. All we need to know is at this point, the starting is the same. So the new paint and the mixed, the starting is the same, but the end, not sure. So we're going to say if the end of the mixed, well, if the end of the paint is bigger than the end of the mixed, then we're going to say temp.append, and then basically chomp off, we try to compare to the next one. So that only happens, this one only happens if mixed one is, let's say, smaller, right? If mixed one is smaller or equal to, that's fine. Mixed one is smaller or equal to what? Mixed one is smaller or equal to paint 1, right? If that is the case, if it's smaller or equal to paint 1, if mixed 1 is smaller or equal to paint 1, then we're going to append this, right? And then paint 0 equals to mixed 1, and that's the new starting point. Else, if mixed 1 is larger, which is this test case, if mixed 1 is larger, if mixed 1 is larger, if mixed 1 is larger, then we're going to say temp.append, paint 0, right, and paint 1, because paint 1 is smaller, and mixture, right? And after doing that, paint is exhausted. Paint 0. Paint 0 equals, no, paint 0 does not equal to mix 1. Paint 0 equals to, paint 0 equals to paint 1. I want to use this, right? So paint 0 equals to paint 1 because we exhaust the entire paint. And then, so we need to append two things, right? This is the first thing we need to append. And then temp need to append another thing, which is the remaining of the mix that has not been mixed, which is going to be paint 1, mixed 1, and mixed 2. So we add these two inside, and then we set paint, basically set paint to 0, and then we go back. And then we say, oh, paint 0 is this. So remaining of the mixed need to go, right? Remaining of the mix need to go to temp. Okay, and then once this is over, we check if 0 is smaller than this when I add the paint. Okay, so let's try this. Now we pass. Right, now we pass. Actually, I should have tried the other one, but it doesn't matter. So we run a few more. Okay, they all pass. Let's increase to 4. Okay, let's increase it to 10. 10 test cases. Okay, let's increase segment length to 10 as well. Oh, this one looks promising. Let's increase this to 100. Okay, let's do here. Okay, section 2, run code, pending, judging. Ugh. Takes 6 seconds. Jeez. Feel like it's gonna time out again. Oh God. Try it. If it time out again, I'm gonna give up. It's already an hour and a half. Oh, doesn't look promising. Nope. I think it's timeout or either wrong or timeout. Yeah, timeout again, but probably go through more cases. Page not found. I click it too fast. Do you want to give up that easy? Oh my God. What the hell? Oh, wait. I'm clicking on view all. They do not let you view it. That's fine. I'm supposed to click this. I clicked the wrong thing. If we get 46, I'll got like 2 more. No, that's still not right. Okay. That is not the case. Now what? Union find. How do we figure union find? Or segment tree. Segment tree. Isn't this segment tree? 1 to 7 we have a value, right? And then 6 to 7, 6 to 8 we have a value, 8 to 10 we have a value. So we just, how long? Wait, can we use segment tree? Well, segment tree is, okay, let me think, segment tree. How do we even set up segment tree? We say, maybe we have segment tree. Now this one, because segment tree is we change like a single value and when you query the result. And this result will be different. Like a query say 3 to 5, the result is not the same. It is not as like two different results. No, it's not segment tree. Union find. How about union find? Well, union is some criteria when the union the value. So we'll have 5, and we have this. Then so we union these. Then what? We have hints. We have hints. Let's go with hints. Hint 1. Can we sort the segments in a way to help solve it? Yeah, I did sort it. Which means something should be happening here. I mean, the cost, right, is we have a queue, we have to go through. Can we avoid it? Let me think about it. Have all these things, right? If we sort based on the starting point, and then we can sort based on the size. So, but that doesn't guarantee, because we sort based on the starting point, so it doesn't guarantee anything, right? So I can have a new one come in, which have the starting point, and then like further, and then it's a very, very short piece, and that's what causes the problem. So how do we handle this? Like, where does this one go? This one's like overlapping with everything. So new one comes in. This old one. That's a new one, right? New one comes in. These two are different. These two are different. And there's no way, because the size is too big, right? N is 10 to the 5th. I think if we do no, that's not gonna work. If we sort based on the end, it's not going to be the same. What if we sort, let's say sort based on the end, or we can sort based on size. If we sort based on size, that's not going to help. So would it help? We find the smallest piece, right, and then the larger piece. Now they could be like very far apart, so it's not going to help. If we sort based on the end, so if we sort based on the end, so the first segment we have the earliest ending, right? But that's not necessarily the. Okay, so the next one will be say like this. Next like be this. So we sort based on the end. We know the new one comes in will always have a slightly larger end. So will this help us? Well, then the new one comes in. Then we never know if anything can be chomped off. Because new one comes in onto the left side. What we know is new one comes in, we'll always have a new piece that's going to be mixed, right? But on the left-hand side, we don't know, right? We don't know. All we know is we can put this piece up in there. This is the mixture part. It's this part. The next one can be like even more to the left. And then I cover the entire thing. No, I don't think so. I think it is to sort based on the left. Therefore, we can know immediately when something can be pushed into the result. Now the pain point I have is if I have something small comes in, and then I immediately have to chomp my previous one into small pieces, because the ones in the middle have different color. And then the next one comes in, I have to go through each one of them. See, that is the trouble. That's why I have this Q, which apparently is not right. This hint is not helpful because we are there already. Let's see another hint. Hint number 2. How can we dynamically keep track of the sum of the current segment? Dynamically track the sum of the current segment. What do you mean by the current segment? Don't know what it means. How can we dynamically track the sum of the current segment? Sort based on the starting point. Then I also say if the starting point is the same. Okay, so if they have the same starting point, right? If we have the same starting point, it's still not helping. Are we talking about dynamic programming in this case? Try it. What if we do, like, in this case, put in a grid? What's going to happen? Wow, that's going to be a huge grid. That's going to be a huge grid. I think it's going to work. Let's say 1, 4. So let's say position 1. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Doesn't matter. So 1, 4 is going to be 5. And then 1, 9. How is that going to help? Wow, no idea. Look at the topics. Prefix sum. Similar questions. That's prefix sum. It is a prefix sum. Right? It is a prefix sum. Hold up. So we have 1 to 4 is 5, right? And then 4 to 7, which means 4 to 7, we can add it. The prefix sum. It's like what? 12. All right, so 4 to 7, everything is 12. And then 9 on top of it. So it's going to be 14 here. And 9 will be 21. All right. No, that's 14. 14, 21. Yeah, that's 21. So 1 to 4, 14. 4 to 7, 21 minus 14. No, that's not 16. Prefix sum. That's why I said 4.5. So everything into 4 will be adding 5, right? Starting to 4 will be 5. Then what? Then I do 1 to 7. So I say all the way to 7. Everything will add to 9.